Welcome back, dear friends. Today we are going to talk about relief valve sizing to protect steam drum. So obviously in this tutorial, we are going to set up a pressure safety valve on a steam line in HYSYS. So let's move to the problem statement. So here is a boiler system. For simplicity, I am taking methane as a fuel, air to burn the methane in a combustor, and then hot gases are being produced that are passing through a shell and tube heat exchanger, where boiler feed water is passing through the tubes and converting into the steam. So here is the steam outlet valve, and we are assuming that due to some reason, if this outlet valve of steam is stuck in a closed position, then obviously back pressure will build up and it will destroy the equipment. So we want to install a pressure safety valve on this steam line, and for this valve the design pressure and design temperatures are given here. So the set pressure is 10 bar. Set pressure is the pressure that if the line reach at this pressure, then this RV will lift up, so it will release the excessive pressure from this line to protect the in if I talk about in real situation is the steam drum. But for simplicity I am just taking this very simple case. So we are going to size this RV. Sizing mean the size of orifice that we have to need, and the nominal diameter of the pipeline to this RV, and as well as the pipeline diameter to the outline of this RV. So let's move to the HYSYS to build up this simulation, and then we will perform the relief valve sizing. So now we are in HYSYS. So the first step, all of you know already that we have to select component. The first one is methane, then oxygen, okay, and after that nitrogen, then carbon dioxide, and then water. Okay, the second step is we have to specify fluid package, and for that we are going with Ping Robinson that will sufficiently fulfill the requirements for thermodynamic property estimation. After that we just go to the simulation environment, and here we are going to select a combustor that is actually a reactor, and for simplicity we are taking a Gibbs reactor. Okay, and another thing that we need here is the heat exchanger, and the last one is a valve. After that just close this one and double click on a reactor. So we have to specify the inlet streams. So one is methane, and the other one is air, and the outlet is hot gas, and the other one is liquid. Okay, just close this one, and after that just double click on it in the exchanger. So the hot gases are passing through the shell side. So on shell side I will give hot gas, and the outlet is flue gas that is going to atmosphere, and the tube side is boiler feed water BFW, and the uh, tube outside is steam. Okay, and go to the parameters, and here for tube side we have a pressure drop that is 0.2 bar, so we will specify it here. So 0.2 bar. Just close this one, and then this valve, double click on it. I will say control valve. Okay, and the inlet is steam, outlet is to plant. Okay, and the pressure drop in a normal scenario, I will say it is 0.5 bar. Okay, so just close this one. Now we have to specify the air and methane. Okay, so let's first specify methane. Double click on methane stream, and the temperature is given 25 degrees C, pressure is given 2 bar, and molar flow rate is 1 mole. Okay, and the composition, because it's pure methane, so we are going to put only 1, and that is okay. Now the fuel stream is specified. The second one is the air, and for air you can see we have pressure, temperature, and flow rate. Okay, so the temperature is again 25 degree, pressure is also same 2 bar, but the molar flow rate is 11 kmol per hour. Okay, now go to the composition, and 0.2 is the oxygen and 0.8 is the nitrogen, and then press OK. So this stream is also specified. So you can see that the Gibbs reactor is already specified, and we have a hot gases at a temperature of around 1800 degrees C. So this temperature is going to be used to produce steam from BFW. And now we are going to specify boiler feed water. So go to the PowerPoint. So here we have the specifications for BFW, that is 100 degrees C, 7.5 bar, and 300 kg per hour. Okay, so temperature is 100 kg, pressure is 7.5 bar, and mass flow rate is 300 kg per hour. And now go to the composition, and here we have only water. Just press 1 and press OK. So this stream is also specified. So to solve the exchanger, we have to specify the flue gas outlet temperature. So the flue gas is passing, because it's going to atmosphere, so usually the temperature of flue gases are not like very low, because there are NOx and SOx. So we calculate in a way that these gases should not condense inside the chimney, otherwise it simply crude the flue gases chimney and reduce the life of a plant. So for a safe side, we are releasing the flue gas at 200 degrees C, and the pressure is almost atmosphere. I will say it's 0.1 bar gauge. Okay, so when I insert these numbers, so you can see that the simulation is already fully specified and then converged. Now the scenario is like that: during the operation of plant, this control valve is stuck due to some reason in the closed position. Then what will happen? Obviously the pressure inside this line and the steam drum or inside the boiler will increase. Okay, so obviously if there is no safety, after some time this will burst and it will be a accident. So to avoid this one, we are going to introduce a pressure relief valve on this steam line before the control valve. So how we can do that? So first let's check the steam specifications. So if we look on the steam stream, so the vapor fraction is 1, temperature is 200 plus, and the pressure is 7.3. So this is actually low pressure superheated steam. Okay, so now we are going to insert pressure safety valve here. For that, go to the left side of the this window and click on safety analysis. So now we are enter into a new flow sheet, and if you look on the top ribbon here, we have three options. We can add pressure relief valve, either we can add rupture disc if we are using some vessels, and also we can add the storage tech protections. Okay, but here we are going to add pressure safety valve. Just click on it and click here. Okay, so we insert pressure safety valve on this steam line. Now we are going to size this valve, so just double click on it. So this new window will open, and now just follow these this yellow line instruction from the software. Okay, so here the operating temperature, the reference is the one that currently we are having, the operating temperature that we have. So that is okay, we are fine. And design temperature is given, that is 220 degrees C. If we look into the PowerPoint here, design temperature is 220, design pressure is 12 bar, and the set pressure is 10 bar. Okay, so operating pressure is 7.3, that is okay, and design pressure is 12 bar. Okay, for example, here I just want to tell you one more thing. If you do not want to have the operating pressure that currently is in operation, and you want to add your own number, you just change from reference to manual and you will able to add your value. Okay, but here I am just going with reference value. After defining the design parameters, okay, I will go to the to set the set pressure for this RV. What is the set pressure? Set pressure is the pressure when it reach into the line, then this RV will lift to release the excessive pressure. Okay, so this RV is being calculated using the design standard of ASME number 6, you can see here. Okay, and the discharge of this RV is going to flare? No, it's going to atmosphere because it's a steam. Okay, and here you can see the set pressure. So at this time by default it's on design pressure. Okay, but for our problem it's said that it should lift at 10 bar. Okay, so how we can do? Just unclick here and write here 10 bar. Okay, so the next step, you can read on this yellow ribbon, it says that create an emergency scenario. For that, go to the scenario and here create a scenario, and then sizing case. Yes, we want to size this one, and the scenario here is the user defined. Just go here. So there are a number of different scenarios that could happen at different places of plant. So according to your possible hazards at your line, you can define more than one scenario and size your valve accordingly. Okay, so here, because we are saying that the outlet valve, that is this one, is blocked and the back pressure is being built, so we are just taking this scenario for the calculation purposes. Okay, then what HYSYS says next? It says we have to select a stream that is going to this this valve. For that, go to this stream tab and double click on it. Then a new window will open. Just a moment here. So this the scenario reference stream, just select, and in our case it's a steam. Okay, and then relief temperature. So we are saying that the relief temperature should be the operating temperature, that is okay, and the relief pressure. For required relieving flow, we are also taking the reference value, that is the maximum flow rate of the steam. Okay, to release the pressure as early as possible. So now on the right hand side, here on this green ribbon, it says orifice calculation completed, and HYSYS completed the orifice that has the orifice diameter is 0.5 square centimeter. Okay, sorry, it's the area. So now we have this calculated value, but we have a standard sizes that are available in market, so we have to select some of any I mean one of them that is available in market. So either you can select by yourself, but if you are not sure, just click on this button, select. HYSYS will select the nearest possible orifice with the calculated number. Okay, so after that, go to again here you can see the fluid properties. So when the pressure is going to change, how the temperature will change, what will be the mass flux during at different pressures. Okay, so you can just analyze and see either it is fit for your case or not. Okay, so just go back to the main PSV calculation. So you can see here the required flow rate when RV will lift is 300 and the rated one is 432, and the capacity used, maximum capacity used is 70%. That is okay, it should not be 100%. Okay, and the orifice area, that the calculated one is 0.5 and the selected one is 0.7. there is a margin, so that is also fine. And the pressure drop, you can see we do not have a pressure drop calculation for this RV. So how we can have the pressure drop calculation here? So for pressure drop calculations, the line pressure drop going to the RV, I will just explain with the line that is attached from stream line to the inlet of RV and the outlet of RV. So we are now going to calculate the pressure drop of these two lines. Okay, for that, go to the RV setup and then go to the line sizing. Okay, so here you can see that the pressure safety valve flange sizes for inlet line and for outlet line is calculated by HYSYS. So now we have to choose the nominal diameter of the pipeline that is going to connect with this flange as well as with this flange. So the best practice is that we have to choose a little bit bigger diameter compared to the flange one. Okay, it's 1, so I am going to choose next 1.5 inch, and similarly here 2, and I will go next to 2 is 2.5. Okay, so after selecting these two parameters, just run the line sizing. So you can see this green tab, the pressure drop check is okay, and to see the calculated pressure drop for inline is 0.2, and the maximum allowable pressure drop is 0.3 for the inlet line, and similarly the outlet line, the calculated one is 0.1, and the maximum pressure drop allow is 1 bar. So this is the way how you can size pressure safety valve in HYSYS. I hope you understand this tutorial and you learn something new. If you like this tutorial, please don't forget to subscribe the channel, like it and share it with your friends. So until next video, bye bye, stay tuned.